In this Easy Ed video lecture, we will learn isometric views, in which we will learn what is isometric projection, isometric axis, isometric lines, isometric planes, isometric scale, 4-center method, isometric views from the given orthographic view, and isometric projection of a sphere.
Hey, it's time to concentrate now.
What is isometric projection? Consider a cube placed in the horizontal plane with its faces equally inclined to the vertical plane as shown. Now if we join the diagonally opposite corners of this cube, then we get the solid diagonal of the cube. Now in the second position, if we tilt the cube in such a way that this solid diagonal is parallel to the ground or horizontal plane, the projections of this cube will be as shown. Now in the third and final step, if we rotate the cube such that this solid diagonal becomes perpendicular to the vertical plane, then the projections of the cube are as shown. What we saw here was the step-by-step procedure to create the isometric projection of the cube. The front view that we see here is the isometric projection of the cube. The word isometric comes from the Greek language, which means equal measure, and reflects that the scale along each axis of the projection is the same. In isometric drawings, the axes are equally inclined to each other at 120 degrees, and the coordinate axes appear equally foreshortened. Next is isometric axis. The lines OA, OB, OC, representing the edges of the cube, are equally inclined to each other at 120 degrees and are termed as the isometric axis. Next is isometric lines. The lines parallel to these axes are termed as isometric lines. Next is isometric planes. The planes representing the faces of the cube and other planes parallel to these planes are known as isometric planes. Now we will see construction of the isometric scale. While drawing isometric projections, it is necessary to convert true lengths to isometric lengths. This is done by drawing an isometric scale. To draw an isometric scale, first draw a horizontal line AB of any length. From end A, draw lines AP and AD such that angle PAB is equal to 45 degrees and angle DAB is equal to 30 degrees. Now mark divisions of true length on AP, and from each division, draw vertical lines cutting line AD. The divisions that we obtain on AD gives us lengths on isometric scale. Let us draw the isometric view of a square plane. Draw a horizontal reference line, and from any point draw the sides AB and AD inclined at 30 degrees. Now from points B and D, draw arcs and mark point C and join the lines BC and CD. This rhombus is the isometric view of the square in a horizontal plane.
Seriously, pay attention. This is important.
Now let us draw isometric view of a circle by 4-center method. A circular plane in the isometric view will be seen as an ellipse and is drawn using the 4-center method. The first step encloses the circle in a square plane, touching it at points A, B, C, and D. Then draw the isometric view of the square plane as shown. For drawing the ellipse, first draw the center lines and mark the points A, B, C, D as shown. Then join the longer diagonal and name the opposite corners 1 and 2 as shown. Now from the corners 1 and 2, draw lines joining the midpoints of the opposite sides. These lines intersect the longer diagonal at points 3 and 4 as shown. Taking 1 as the center, draw arc. Then taking 2 as the center, draw arc. Next, take 3 as the center and draw the arc, and then take 4 as the center and draw arc. Next, let us draw isometric view of an object. Draw the isometric view of the object from the given two views. From drawing the isometric view from complex orthographic views, we first identify the overall length, breadth, and the height of the object. The given two views are the front view and the top view of the object. Now concentrate on the front view. The horizontal lines in the front view represent the length, whereas the vertical lines represent the height of the object. Similarly, In the top view, the vertical lines represent the breadth of the object. Hence, from the given views, the overall length of the object is 50 mm, the overall height is 10 mm, and the overall breadth of the object is 30 mm. Now, with these dimensions, draw a block with its sides inclined at 30 degrees to the horizontal reference line as shown. Now number the planes and name the corners in the given views as shown. Choose the orientation of the object such that maximum components of the object are visible in the isometric view. Line BC in the front view corresponds to plane 2 in the top view, whereas line FG in the front view corresponds to plane 4. Locate the corners of the planes 2 and 4 in the isometric view and join the lines OL and PK as shown. Continuing, we see a hole of 10 mm diameter on a plane 4. Locate the center of the hole and draw the hole using the 4 center method. Next, we see a fillet of 10 mm radius on plane 2. To draw the fillet, first locate points O and N in the isometric view and draw perpendiculars from the points as shown. The perpendicular lines will intersect at a point. Taking this point as the center, draw ON. Then, to draw the circular surface on the lower side, draw a vertical line of length 10 mm from this point and draw the lower surface of the arc. Now draw a vertical line of 10 mm length from this center and draw the fillet on the lower face as shown. Join the two arcs with common tangents and remove the excess portion. Now line DE corresponds to plane 3 in the top view. Also from the front view, plane DE is 5 mm below the planes 2 and 4. Hence locate the corners of this plane in the isometric view. Draw the arrow showing the position of the observer.